In this problem, we're going to use the distance equals rate times time equation to solve. And what we want to do on a distance equals rate times time equation is find out what distances do we know, and then what's the best way to go about and solve it. Sometimes actually you know something about the rates, like the rate of one plus the rate of other, or how the rates relate to each other. And there's some different ways of going through these problems, but this one's relatively straightforward. And so if we think about what's happening in this picture, you've got Kanga, who's 45 meters ahead of Rue. And so, basically here is Rue, let's put Rue over here. And then you've got Kanga here. And then what's going to happen is they're going to start traveling. And at some point, in terms of time, they're going to be at the same spot, which means Kanga is going to, or Rue is going to catch up to Kanga. And that's the goal of this problem, is when does Rue catch up to Kanga? And it says, how many hours does it take? And so what it actually implies is that their time is going to be the same, because they're both jumping for this entire time frame, and we want to find out how long does that take. So if you think about what's happening, well, the distance, and what I'm going to use is subscripts, and so the distance of Rue is going to equal the distance of Kanga plus 45, because Kanga gets a 45 meter head start, and so you've got to add 45 meters to Kanga's distance to make it equal to the distance that Rue's going to have to travel if they catch up to each other. You're actually given the rates, even though you don't quite see it. You can think about it in terms of meters per hour, and so we can just call the rate of Kanga is 20 meters per hour, and the rate of Rue is, 25 meters in 2 hours, so 25 halves meters per hour. And then in terms of time, their times are the same, we just don't know what they are. And so in this problem, since their times are the same, this was rate of Rue, we're just going to let the time of Rue equal the time of Kanga, and so it doesn't matter which one we decide to use, the time of Rue or the time of Kanga. So we plug that into this formula, rate times time. So for Rue, the rate is 25 halves. And the time, we'll just use time of Rue in this problem, because it says how long does it take Rue to catch up. And then that's going to equal, the distance of Kanga is going to be the rate of Kanga, which is 20 times the time of Kanga, but I'm just going to plug in the time of Rue because they're the same, so we have one variable, and then plus 45. Pretty easy to solve now. I just need to subtract 20 time of Rue from both sides. So I need to subtract these, so I'm going to do common denominator of 6, and so what, 75 over 6 minus 40 over 6, and so it's going to give you 35 over 6, so you've got 35 over 6 equals time of Rue equals 45 meters. And so you're going to have this rate times the time of Rue equals 45 meters. So you just multiply both sides by 6 over 35. There's a little bit of cancellation that can happen here. 5 can cancel out of both of these, and so you're left with a 7 and a 9. And so the time it takes Rue to overtake Kanga is going to be 54/7 hours, or you could think about it as 7 and 5/7 hours also. That's how many hours it takes for Kanga to catch up with Rue. So again, this was our key equation. Probably the hardest part of the problem was coming up with that equation. Then after that, we had to do a little fancy work with the fractions, but nothing that a good math student should not already know how to do. And then we just solved to get 7 and 5/7 hours.